With the help of this chi-square distribution table, we will be able to decide what are the degrees of freedom and what are the confidence level for each degree of freedom. So levels are different groupings within the same independent variable. For large data sets, it is best to run an ANOVA in statistical software such as R or Stata. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 3 of Unit 5, we will be learning about the chi-square distribution table. So in my previous sessions, I have already told you about the chi-square distribution. So in the chi-square distribution table helps us to determine the confidence level and also the degrees of freedom. And it is one of the methods through which we can test the hypothesis. Now we all know what is hypothesis, and with the help of the chi-square distribution table, we will be able to test the hypothesis. So whether it is the null hypothesis or whether it is the alternative hypothesis. So here let us learn about the chi-square distribution table. So the chi-square distribution table with 3 probability levels is provided here. So we have the chi-square distribution table in the next slide. The statistic here is used to determine whether distributions of certain variables vary from one another. So we will be able to determine whether the distribution of certain variables, how they are varying from one another. So the categorical variable will produce data in categories and numerical variables will produce data in the numerical form. So with this, we can see that in this slide, if you can see, here we have the degrees of freedom up to 12, and here we have the confidence levels on the horizontal scale, and in the vertical scale we have the degrees of freedom. So with the help of this chi-square distribution table, we will be able to decide what are the degrees of freedom and what are the confidence level for each degree of freedom. For example, if the degree of freedom is 12 and the confidence level is 0.975, then we can determine the value as 4.40. So with the help of this table, we will be able to analyze whether we can just test the hypothesis. Then what are groups or levels? So levels are different groupings within the same independent variable. For example, the independent variable is the X. So the levels may be non-organic, organic, free-range organic. So the dependent variable could be the price per dozen eggs. So here we have what are groups and levels with relation to the research methodology. So the levels are different groupings within the same independent variable. So suppose you take the independent variable as the X. Then the levels, how can you group the eggs? So eggs can be grouped as non-organic, organic, free range, organic, etc. And the variable could be the prices. For organic, the prices of the eggs will be high. For non-organic, low, and free range organic, it will be varying between these two. So in this way, we can decide about the groups or the levels. Then the next one is the understanding the F value. The test statistic for ANOVA is denoted as F. The formula for ANOVA is F equals variance caused by the treatment or variance due to the random chance. So the ANOVA F value will tell if there is a significant difference between the levels of independent variable when P is less than 0.5. So a higher F value indicates the treatment variables are significant. So with the help of this ANOVA F value, we will be able to analyze if there is a significant difference between the levels of the independent variable. Note that the ANOVA alone does not tell us specifically which means were different from one another. To determine that, we would need to follow up with a multiple comparison or the post hoc test. So this ANOVA alone, with the help of ANOVA alone, we cannot tell about the means. but we need to have other tests also. Then, when the initial F test indicates that significant differences exist between group means, post hoc tests are useful to determine which specific means are significantly different when you do not have specific hypothesis that you wish to test. So, with the help of this, the initial F test, it will indicate that the significant differences exist between the group means, but the post hoc test will tell us which specific means are significantly different. So, the post hoc test, they compare each pair of means like t-test, but unlike the t-test, they correct the significance estimate to account for the multiple comparisons. So, the post hoc test, so here we have a comparison of the means and then each pair of means, but then they correct the significant estimate to account for the multiple comparisons. Then, what do we mean by replication? So, replication requires a study to be repeated with different subjects and different experiments. This would enable a statistical analyzer to confirm a prior test by testing the same hypothesis with a new sample. So, replication means you duplicate it or you repeat the same experiment with different subject and different experiment. So, why do we do this? It is for testing the same hypothesis with a new sample. Then, how to run an ANOVA? For large data sets, it is best to run an ANOVA in statistical software such as R or Stata. So, this ANOVA software, it is usually we use the R or the Stata to run the ANOVA software. So, for again, we have an example here. So, non-organic, organic and free-range organic eggs would be assigned quantitative values and would serve as our independent treatment variable, while price per dozen eggs would serve as the dependent variable. Other erroneous variables may include brand name or the laid egg date. So, in this we have this example here. So, if we take the example of the eggs, then we can group them as the non-organic, organic and the free-range organic eggs. Then, we can analyze them with the help of assigning them the values. So, if the non-organic is 1, organic is true and the free-range organic is 3, and they will be serving as the independent variable, and whereas the price per dozen, that would serve as the dependent variable, and other erroneous variables. So, you can have any number of variables. So, for the eggs also, if you have the brand name or when the egg was laid date, all this if you can add, then you can have some more variables in this kind of a data analysis. Then, using data and ANOVA command in R, we could then determine the impact egg type has on the price per dozen eggs. Suppose if the eggs are organic, and then next we have the laid date of the egg. Then, so in this way we can see that the price varies. So, if it is the latest date on which the egg is been laid, then the price will be more. But if the date is very 2 or 3 days old, then the price will fall. So, we can analyze how the price of the egg has risen or fallen based on the laid egg date. Then, next one, t-tests and ANOVA tests are both statistical techniques used to compare differences in mean and spreads of the distribution across the population. So, we use the ANOVA test and the t-test to compare the means. So, and the spreads of the distribution across the population. So, whenever we are analyzing a study of the sample, whatever we have collected, we need to compare the differences in means and the spreads of the distribution, whether it is the normally distributed data or whether it is the skewed data. The t-test determines whether two populations are statistically different from each other, whereas ANOVA tests are used when an individual wants to test more than 2 levels within an independent variable. So, the t-test will determine whether two populations are statistically different from each other, whereas ANOVA test, so t-test will tell us about whether the population is statistically different from each other, whereas the ANOVA test, it will tell us whether when an individual wants to test more than 2 levels within an independent variable. Then, referring back to our example, testing non-organic versus organic would require a t-test, while adding in free range as a third option demands the ANOVA. So, if it is a t-test, we can do it only with the help of two variables, but if there are more than two variables, then we have to use the ANOVA. Rather than generate a t statistic, ANOVA results in a F statistic to determine statistical significance. So, what is the result of ANOVA? ANOVA, with the help of ANOVA, we can get the F value. So, F equals the variance. So, that value we can get with the help of ANOVA. Analysis. ANOVA is an analysis tool used in statistics that splits an observed aggregate variability found inside a data set into two parts, that is systematic factors and random factors. Now, if you are given a data, then with the help of the ANOVA analysis, we can just segregate them as the systematic factors and the random factors. So, whatever data is given, so when we are analyzing the data, we can just see that there are two factors here, that one is the systematic and the random. The systematic factors have a statistical influence on the given data, while the random factors do not have. Now, they will have an effect on the data, whereas the random factors, they don't have any effect on the data. So, the analysts use the ANOVA test to determine the influence that independent variables have on dependent variable in a regression study. Then, the t-test and the z-test methods developed in the 20th century were used for statistical analysis until 1918, when Ronald Fisher created the analysis of variance method. Now, who invented this ANOVA? So, this ANOVA was invented by Sir Ronald Fisher. So, he was one of the greatest statisticians who came up with this ANOVA method. So, with the help of this ANOVA, we can always have a good analysis of the data, whatever we have collected. Then, ANOVA is also called the Fisher analysis of variance, and it is the extension of the T and the Z test. So, the term became well known in 1925 after appearing in a Fisher's book, Statistical Methods for Research Workers. So, it was employed in experimental psychology and later expanded to subjects that were more complex. So, this kind of a method, ANOVA method, it became well known in 1925, and then it was employed in experimental psychology, and later on it was expanded to other subjects which are more complex. So, analysis of variance, ANOVA, is a statistical method that separates observed variance data into different components for use for additional test. Now, one-way ANOVA is used for 3 or more groups of data to gain information about the relationship between the dependent and the independent variables. So, in this ANOVA, we have two types, that is the one-way ANOVA and the two-way ANOVA. In the one-way ANOVA, they have an analysis of only one variable, and in the two-way ANOVA, they have an analysis of 2 or more variables. If no true variance exists between the groups, the ANOVA's F ratio should be equal to or close to 1. With this, we come to the end of this session. Hope you have all followed it. Thank you.